Mitchell, Nader.
Working with rational exponents. Okay, so a rational exponent is essentially a base that is to the power of a fraction. Okay, we can rewrite it by calling it the root of that number. So for instance, you guys are used to seeing the square root of something. So let's say we had the square root of 64. Well, technically they don't write a number there, but technically the number there is a 2. And that can be rewritten as 64 to the power of a half. Okay? So these are interchangeable with each other. With that being said, let's say we had a fraction that had a number other than 1 on top and a number other than 1 on the bottom. We can rewrite this by making it the root of that number and the base to that exponent. Okay? Now, it actually does not matter what order we do it in, whether we find the first, second, third, fourth, fifth root, or we find the power first. You'll both times end up at the same answer. So we're going to go into a complex question in a minute, but I think we should go through a simpler one just to start off here. Let me quickly make it up here.
Hey, we're back.
We're back. So, we're going to focus on this question here. We have 27 to the power of 2 over 3. So what we're going to do is we're going to rewrite it in this form. Okay? So the number on the bottom is the root, it's 2. So we're going to be looking for the third root of 27. In other words, a number times itself 3 times. That is equal to 27. Okay? So when we go to rewrite this, you get the third root of 27. And like we said, the number on top is a power of 2. I can put it in and do 27 to the power of 2 first and then the third root, or I can do it after. And I'm going to do it after in this case, okay? Because the third root of 27 is a number I actually know. Does anyone know what number times itself 3 times equals 27? No? 9. 3. 3 is the third root of 27. So that leaves us with the value of 3 squared. Now, 3 squared is equal to 9. Okay? So we've just evaluated a base that is to a fractional exponent. Okay? So using the rules we've learned before, we're going to simplify this and hopefully we can then evaluate it after. So the very first one, we have the power of a power. When we multiply fractions by each other, we'll have to turn the one number into a fraction. Okay? So we'll turn 7 to 7 over 1 and we'll be left with 6 over 1 times 7 over 1. When we multiply fractions, we do the top by the top and the bottom by the bottom. We're going to then be left with 8 to the power of 7 over 6. Okay? On the bottom, we're multiplying 2 values. So we have to add these fractions. Well, in order to add these fractions, we need a common denominator. So I'm going to turn them both to a denominator of 6, which will make this 3 over 6 plus 3 over 6, and the other number will become 2 over 6. In the end, will equal what?
Well, oh no.
5 over 6. So always remember, when we're adding fractions, our denominator stays the same. So we're left with 8 to the power of 5 over 6, which is good. The last step we need to do here, because this is division, we'll have to subtract these two. We subtract the top one from the bottom. So 7 over 6, subtract 5 over 6, which will give us 2 over 6 as an exponent. So we've now simplified this to one base value to the power of 2 over 6. We're going to reduce this fraction to make it simpler for us. So what would the reduced form of 2 over 6 be?
1 over 3.
1 over 3. And that now gives us a fractional exponent, which means we're going to be looking for the third root of the value of 8. What number times itself 3 times is equal to 8?
2.4.
No, but you're very close.
2.5.
2. 2 times 2 is 4, times 2 again is 8. So,
Wow.
our actual evaluated answer in this question is the value of 2.
Wow.
Okay, we'll do one more example. This one just wants you to simplify and write as a positive exponent. Okay, so we have to put our answer as a positive exponent in the end. There's nothing to evaluate because our base is a variable. So we have to go through the same rules. Very similar to the last one we've done. What we have on top is 2 bases that are the same multiply. So we're adding those 2 fractions. So if I were to add these fractions, 1/2 plus 3 over 2, what do we get? 4 over 2, which can be simplified to 2 over 1, or just 2, right? Let's just keep it as 2. So we now have a to the power of 2. That makes things much simpler on top. And on the bottom, okay, we have to, because this is a power of a power, we need to multiply these values. So negative 2 times 1/2. When we multiply them, we want to make both fractions. So top by the top, by the bottom, it's going to give us negative 2 over 2. Negative 2 times 1 is 2, and 1 times 2 is 2, which gives us what value? Negative 1. So we now have a to the negative 1. The last thing we need to do is subtract these exponents. So we take 2, subtract negative 1. What are we going to end up with? 3. That's it. So, actually, this question ended up being very simple. It's a to the power of 3. This is already a positive exponent. Now, for argument's sake, let's say this said a to the power of negative 3. How would I turn that to a positive exponent? We take this whole number, like a fraction, and we invert it. So now it becomes 1 over a to the power of positive 3. Okay? So this was our answer, but if we'd had a negative answer, that's how we would have turned it into a positive.
You always wanted a positive answer?
If it says put in positive form, then yes.
So what in